sir.
Rizkia.
Present, sir.
Intifada.
Present, sir.
Hanifa. Hanifa. Maulida. Vicky.
Present, sir.
Yohanes.
Present, sir.
Melinda.
Present, sir.
Indira.
Present, sir.
Okay. Let me check again. Aisyah, Riza, Yoga, Niscaya, Hanifa, Maulida. Still away. Okay. Last week, you already learned how to calculate quantitative data using one-way between group ANOVA. Now, I would like you, some of you, to show your work so that we can have a look at your work together and to know whether the calculation is correct, the interpretation of the work is also okay. Any volunteer? Ada yang mau coba tunjukkan one way-nya? Niscaya?
Yes, sir.
You want to show your work one way? One way between group?
Oh, I'm sorry, sir. I use my phone. But maybe you can share our.
I also use my phone, so I cannot share screen.
Other students?
May I, sir?
Sure. Rahmalia. Okay, you can share yours.
All right. So, here is the research question. Is there any significant difference in students' vocabulary achievement between introvert, extrovert, and ambivert students? And this is the first table. It shows the mean score of introvert, extrovert, and also ambivert. And the next table is about the Levin test. And this is about the ANOVA. And it shows that there is a significant difference here because it is 0.00. And then for the post-hole test, here, wait a minute. Yes. Here it shows that from introvert to extrovert, introvert and extrovert students, it shows that there is no significant difference here. And for introvert and ambivert, there is significant difference here, it shows. And for extrovert and introvert, it seems as the first one, there is no significant difference. And extrovert and ambivert, yes, there is significant difference here. And it's same ambivert and introvert, there's significant difference. And also for ambivert and extrovert, there is a significant difference here. And for the interpretation, so yeah, here it is. This research employed a one-way ANOVA to compare the significant difference in students' vocabulary achievement between introvert, extrovert, and ambivert students. The results showed that the significant difference at the p less than 0.05 for three personalities, F2 and 31. It is shown in the first table, if I'm not mistaken. This one, in this one.
Yeah, degree of freedom.
Yes, and then P, and then yeah, until yeah, here it is.
Okay, thank you very much, Rahmalia. Okay, scroll up, please. Okay, the research question. Yes, this research question can be addressed using one way between group ANOVA. The independent variable here is what is what? The independent variable.
Independent.
Independent.
Wait, the three personalities.
The personalities, okay. Introvert, extrovert, ambivert. Okay, the personality type. And then the dependent variable is vocabulary achievement. Okay, now we'll see the descriptive statistic, especially the mean score. We can see the difference of the means between ambivert and introvert is quite large, 4.5 and 3.5. So without looking at the result of the ANOVA, we can guess that there is significant difference, even though we need to check whether statistically they are different as well. Okay, scroll down, checking the Levin's test, it is good. The assumption of homogeneity of variance, significance is value is greater than 0.05. It means that we met the assumption of the homogeneity of variance. Scroll down. Okay, this is the result. We can have a look at the significant value less than 0.00, less than 0.05. In this case, it is 0.00. And then scroll down. Yep, the post hoc test, we can see the means difference between introvert and extrovert is 0.4. So it is not significant, but between introvert and ambivert, the means difference is 1.106. That's why the significant value is 0.001. It means there is a significant difference between introvert and ambivert. And there is also significant difference between extrovert and ambivert with the means difference 0.64 and the significant value is 0.005. Okay, so now we'll have look at the report. The research employed one way between group ANOVA to compare the significant difference in student vocabulary achievement between the three groups. The results show that significant difference at the p less than 0.05 for the three personalities, blah, blah, blah. Okay. Post hoc comparison using Taki HST showed that the mean score of introvert students has significant difference. So ambivert students, okay. Besides, there is this similarly things happen toward extrovert to ambivert students. The mean score, the mean score of ambivert student also has significant difference. However, the mean score of introvert has no significant difference to blah blah blah. The effect size is large since the score calculated using eta square is 0.51. Nanti ya digunakan poin Mbak ya, bukan koma.
Oh, yes.
Oke. Effect size itu diberikan kepada semua multiple comparison sebenarnya. Jadi bukan satu saja. Jadi between extrovert and ambivert, which is also significant. The mean score of introvert has significant. Yeah, introvert and ambivert. You need to show the effect size, and also between ambivert and extrovert.
So there are 3 effect size, right? Sir?
Iya, ambivert, the first introvert, ambivert. Oh yeah, okay. Okay, excellent, Mbak. Thank you very much, Rahmalia.
Sir, actually, it is my work and Riza's work.
Iya, Riza, Rizky, Diva.
Yes. Thank you.
Rizky, Diva. Okay, thank you very much. Any other students who want to show the work? Yep, any other students? Once more. Still sleepy after sahur? Okay. If there isn't any student who wants to show the work, and then we'll resume our lesson. Well, this morning we are going to learn about non-parametric tests, which are the equivalents of the test and ANOVA. Yep, non-parametric test. The type of the non-parametric test that we will learn here is actually the equivalent of the test that we already learned. That is ANOVA and t-test. So actually, this is not that difficult because the function is pretty much similar. For example, like this. The non-parametric and parametric test. Mann-Whitney U. We will use Mann-Whitney U if it is not possible to use independent sample t-test. Because it is not possible to use independent sample t-test, then we use Mann-Whitney. Or if it is not possible to use pair sample t-test, which is parametric test, we use Wilcoxon. Or if it is not possible to use one way between group, like what you already, the Mahmalia already presented, and we use Kruskal-Wallis, or one way between to measure ANOVA, and then we use fragment. But today, we only focus on Mann-Whitney and Kruskal-Wallis, which is what common to be used. The question is, why do we use non-parametric tests? For example, you already have a research question. You already have the data. You already collected the data using questionnaire or a test. But once you collect the data, you check your data, the data is not normally distributed. The data is skewed, severely skewed. Datanya tidak normally distributed, model seperti bell shape. Skewed to the left, skewed to the right. So it is not possible to use the parametric one, independent sample t-test or ANOVA. Or your sample is very few. Maybe you only have 20 participants, 25 participants, or maybe 15 participants, which is not, which is very likely that you will not get normally distributed data. Jadi kalau partisipannya sedikit, kecil kemungkinan itu datanya normal. Jadi kalau data tidak normal, salah satu ikhtiarnya adalah untuk membuat menjadi normal adalah you add the participant. Tapi jika ditambah kok tetap saja, maka the last resort is you use non-parametric test. Tapi mana yang di-prefer? Of course, we prefer parametric one, t-test or ANOVA, because it has more power to detect significant difference. Or maybe the reviewer or the examiner follows a school of thought that ordinal data like Likert scale should use non-parametric test. Jadi di antara statistician, para ahli statistik itu, termasuk researchers, quantitative researchers, itu ada dua pandangan. Satu, pandangan bahwa if you have ordinal data, like Likert scale agree to strongly disagree to strongly agree itu yang 1 sampai 5, 1 sampai 6, this is called ordinal data. If your data is like this, then you should use non-parametric test. Jadi ada aliran yang seperti itu, harus pakai non-parametric test. Meskipun ordinal datanya itu dibuat agregat. digabungkan menjadi min score. Jadi seperti yang data Anda pakai itu, kan tentang language assessment literacy, kalau per item itu kan ordinal data, 1 sampai 5 skornya, atau 1 sampai 6. Tapi kalau sudah digabungkan, seperti designing test instrument, itu kan rata dari 5 pertanyaan, 5 item. Itu kalau menurut sebagian orang, itu sudah bisa dianggap sebagai continuous data, tapi sebagian statistician tetap menganggap itu original data, karena itu tetap like a skill. Oke, ada juga sebagian dari statistician yang menganggap bahwa original data jika itu dibuat rata menjadi gabungan, menjadi skillnya, bukan itemnya. Kalau item pertanyaan, setiap skor di setiap pertanyaan itu tetap original data. Tapi kalau sudah digabungkan, 3, 4, 5 item pertanyaan dijadikan satu skornya, menjadi ratanya jadi min skor itu, atau agregat, sudah dibuat agregat, maka itu disebut continuous data. Karena sudah continuous data, maka boleh menggunakan parameter tes seperti t-test atau ANOVA. Okay, now we will learn the first type of non-parametric test, which is the equivalent of independent sample t-test, that is Mann-Whitney test. So the function is the same. When you have, if you want to compare two different group on a dependent variable. For example, your research question. So the research question is actually the same. Research questionnya sama. Jadi seumpama sudah punya research question, sudah punya data, awalnya mau desainnya pakai parametrik, tapi datanya ternyata sangat tidak normal, ya berarti harus pindah dari independent sample t-test ganti menjadi Mann-Whitney. Jadi seperti itu case-nya. Atau memang dari awal Anda termasuk pengikut yang saya sampaikan tadi, statistician itu. Karena data Anda adalah data ordinal, maka ya sudah dari awal tentukan saya harus pakai non-parametrik. Nggak boleh kalau Anda mengikuti aliran seperti itu. Jadi nanti yang dipresentasikan bukan mean score, tetapi median. So the same, the variable is the same, one categorical variable with two groups, and one continuous variable. Once you run the SPSS to check the Mann-Whitney test, what you need to interpret is the Z value and also significance value to know whether which group has higher level in terms of the dependent variable. Of course, you need to check the mean rank, which is stated or written in the rank table. But remember, the median value is preferred to be presented in the test result. When you report, median value is preferred. Jadi kalau menurut APA dan praktek di dalam APA itu, yang lazim digunakan dan lebih dipilih adalah melaporkan median, not the mean rank. And then how to calculate effect size is quite simple. Z value divided by square root of n. N is the total number of the participant. To determine whether the effect is small, moderate, or large, we use this one according to Cohen. This is the example. A Mann-Whitney test was conducted to examine if there was a significant difference in English score across gender, the result revealed no significant difference in the English score of males. Look, MD here is the median. The median is 35, N is the number of participants, median, and then U is the man with U, and then this is the score value of the man with U, and then Z score, and then P value. R here is the effect size. This is another example. This is from my own project dari penelitian saya sendiri. Man with U test was conducted to examine if female and male students differ in the use of cognitive, affective, and metacognitive strategy categories through visual inspection of histogram. The distribution of the use frequency of the three categories were fairly similarly shaped, allowing for comparison of the median of strategy use for the two groups. Female student median and was significantly more significant in cognitive strategies than male students. U, Z value, P value, R, the effect size. Female students were also greater for blah, blah, blah. Male medians, U, Z value, and then P value, and also the effect size. However, there wasn't no significant difference in the frequency of metacognitive strategy use between male and female students. So this is the example. Okay, now we will practice how to run Man Whitney U test. Okay, for example, using the data we already have, dari data yang sudah kita miliki tentang LAL, Language Assessment Literacy. For example, I want to examine whether there is a significant difference between male and female teachers in their ability to develop blueprint or test specification, in their ability to develop various performance assessment, to develop various test item. Jadi saya analisis, saya melakukan banyak tes menggunakan cross keluar Man Whitney U. Saya ambil beberapa nanti ini. Jadi barangkali nanti ada yang signifikan. Oke. Click analyze. And then non-parametric test, legacy dialog, and then two independent samples. I move all the very dependent variable of interest into the variable list, and then the group is the gender. I need descriptive information, and then I checked off the Man Whitney U test. This is actually the it's already by default. And then group 1, 2, continue, and then okay. Here we are. You can see the mean score of each independent variable, of dependent variables. Okay, we'll see the mean rank between female and male for the 558. It seems that male has higher ability than female teachers in developing blueprint, but we are not that sure whether the difference is significant or not. Of course, we need to check the result of the men with NIU. We can look at the significant value 0.01. So we can see that only in the ability or the literacy in developing blueprint or test specification, male and female teachers differ significantly because the p-value is less than 0.05. In this case, it's 0.01. While other items like developing various performance assessment, developing various test items, and also others like developing holistic and also analytic rubric, the significant values are greater than 0.05, like this one, 0.0, 0.2, 0.2, 0.9, 0.8, and 0.7. Okay. As I have mentioned before, what we report is not the mean rank itself, but the median. But look at this table. The table doesn't include median, only the mean rank. Look at this one. This is also the mean score. In this case, we don't have any information about the median, only the men with NIU value and also significant value. So we need to check the median. We need to get the median score. Analyze, compare means. We'll move all the variables of the dependent variables of interest to the dependent list box, and then gender, the dependent list, and then option, and move this to the statistic. And then remember, I want to know the median. So I move the median to the cell statistic and then continue. And then, okay. Yep, we already get the median. The median score of the blueprint and blueprint or test specification is 4 for female and 4 for male. Jadi mediannya sama antara male sama female. Okay, so this is the way we run the men with NIU test to answer research question, which can also be addressed by independent sample test. But because of the data which is not normally distributed or skewed, then we use this one. Or maybe because the participant is very few, we use men with NIU. Or because of the paradigm of some statistician, for example, the reviewer atau pengujinya, pokoknya kamu harus menggunakan non-parametric test jika datamu ordinal. Kalau sudah ketemu orang seperti itu, Anda harus ngikut. Meskipun Anda sebenarnya yakin bahwa data saya normal, partisipan saya banyak. Tapi kalau dia pengikut mazhab itu, pengujinya, Anda harus ikut. Pengalaman seperti itu yang saya pernah alami, jadi akhirnya saya yang awalnya menggunakan parametric test, harus saya rubah. Meskipun saya punya argumen yang sangat kuat menurut saya, bahwa analisa saya menggunakan parametric test itu oke. Justified, dan menunjukkan sejumlah referensi yang menurut saya lebih banyak, bahkan sudah membantah argumen dari reviewer tersebut. ketika saya nulis tentang ini. Oke, jadi akhirnya data semuanya saya rubah menjadi non-parametric test. Look, median. Jadi mulai dari descriptive statistic pun, the data which I presented was median score. And then look at this one, Kruskal-Wallis. Jadi ANOVA-nya non-parametric test. This is the way I report. Habis ini yang kita bahas itu, Kruskal-Wallis. So, look, the one I report is median score 3.4, 4.5. So only the median. Okay. Any question?
Sir, may
Yep.
I ask?
Okay.
Is there any possibility if the median has different value in the report table?
Definitely, yeah.
So if there is different values, what should we do? Is there any additional thing to do or not?
If the median values between male and female are different, for example, the male value has higher median score, it is easier for us to determine, yes, there is a significant difference in the vocabulary test between female and male. Which one is better? Of course, we check which has the greater median value. Jadi yang median value-nya lebih tinggi berarti dia ada perbedaan signifikan. Mana yang kemampuan lebih tinggi? Ya dari median value-nya. Tapi tadi, look at the result from my example. All the median score are 4, 4, 4, 4, 4. So this is difficult to know which one has a better ability in developing or designing test specification. Yang membuat kisi-kisi soal itu guru laki-laki atau perempuan. Tadi kesulitan karena medianya semuanya sama, 4, 4, 4. Maka kita harus lihat di min rank. Min rank itu tadi kelihatan kan perbedaannya jauh, 45 sama 58. Nah, dari situ kita bisa tentukan, guru laki-laki punya kemampuan dalam mendesain kisi-kisi lebih bagus daripada guru perempuan, karena min rank-nya laki-laki tadi 58, sedangkan perempuannya tadi 45. Memang menurut saya kelemahannya kalau median itu. Kelemahan median itu relatif nanti angkanya sama. Enggak, perbedaan pun jarang. Apa perbedaannya enggak mencolok. Kecuali datanya adalah data continuous. Kalau data continuous itu kan sangat beragam. Tadi datanya ini kan data item like item. Jadi jawaban dari siswa 1 sampai 6 atau 1 sampai 5. Anak-anak kalau ngisi kuesioner itu kan ngisinya kemungkinan itu di angka 3 sama angka 4. Jarang yang angka 5 atau angka 2. Akhirnya median score-nya itu juga kemungkinan di angka-angka itu 34, 34, 34 gitu.
Alright,
Is it clear, Mas?
Yes, sir. It's clear.
Okay.
Thank you.
Okay.
Sorry,
Yeah.
may I ask?
Sure.
I have a confusion about the table that we have to present in the reporting. According to your example on the PowerPoint, I didn't see any table.
Yeah.
Then,
without any table, yeah.
So, which table that we have to present, or it's indeed that there are no table at all, or how, sir?
Okay. It depends on the number of tests you run. If you only have 1 or 2 or 3 main Whitney U test, then I don't think it is necessary. Nggak perlu. You only present the result in paragraph. Like the example in the PowerPoint I give to you. Itu karena itu contoh real, contoh nyata dari penelitian saya sendiri. Seperti itu. You don't need any table. Kenapa? Kalau diberi table, akan kuat repetitif, redundant. Datanya akan sama nanti. It is different from Kruskal-Wallis, which is like ANOVA. Bahkan di tes juga sama, independent sample test Anda tidak perlu yang namanya table. Tapi nanti kalau Kruskal-Wallis yang seperti ANOVA, kita butuh nanti tabel. Jika, if you run a series of Kruskal-Wallis, a series of ANOVA, jadi ANOVA-nya atau Kruskal-Wallis-nya itu beberapa kali, maka kita perlu menyajikan dalam sebuah tabel yang habis ini kita bahas. Tadi sudah sekilas saya tampilkan dari salah satu artikel saya. So, is it clear, Mbak?
Okay, so we only compare the median. The median, the median score. Okay, sir, thank you.
Okay. Yep. Okay, now we'll continue to Kruskal-Wallis. Okay, Kruskal-Wallis, yeah. Kruskal-Wallis, as I have mentioned before, that Kruskal-Wallis is non-parametric equivalent, one way between group ANOVA. So when you have research question, which should be addressed using ANOVA, but because of your data are not normally distributed, or because your participant is quite few, then you use Kruskal-Wallis. For example, if you have a research question, is that a significant difference in self-efficacy level across 3 age level? Jadi ada 3 kelompok usia. Age 18 to 29, 30, 44, and above 45. And then this is the category. It means that we need to have 3 groups. Tadi kalau 2 kelompok ya main Whitney U, kalau 3 kelompok ANOVA atau Kruskal-Wallis. And then 1 continuous dependent variable. Jadi kalau ANOVA tidak bisa, one way yang ANOVA, maka kita larinya ke Kruskal-Wallis. Okay, the information that we need to check when we already get the Kruskal-Wallis SPSS output is check the chi-square value, degree of freedom, and also significant level, and also the mean rank. Like the main Whitney U, the information we need to report is also the median. In ANOVA, the one you learned last week, we also have post hoc test in Kruskal-Wallis. Jadi di Kruskal-Wallis pun kita juga bisa melakukan post hoc test. Sayangnya, unfortunately, in the SPSS, the Kruskal-Wallis doesn't have the post hoc test output. Jadi ketika melakukan analisis menggunakan Kruskal-Wallis, tidak otomatis ada data hasil terkait dengan post hoc test. But you need to do some follow up Man-Whitney-U test. Tapi harus melakukan tes menggunakan Man-Whitney-U. Jadi seumpama tadi Man-Whitney-U testnya antara kelompok usia, ini ada 3 kelompok usia, 3 kelompok usia ini 18 sampai 29, 30 and up to 44 and above 45, 45 and plus. You need to run 3 Man-Whitney-U test. 18 this group, 18 up to 29 and 34 and 44, group 1 dan group 2, and group 1 and group 3, group 2 and group 3. Jadi 3 kali melakukan Man-Whitney-U test untuk pengganti dari Kruskal-Wallis, pengganti dari post hoc test. Yang sebenarnya bisa dilakukan kalau Man-Whitney-U tadi kan gampang, sudah langsung bagian dari ANOVA. Tapi kalau di sini enggak, harus terpisah, melakukan sendiri. Dengan 3 kali Man-Whitney-U. Karena tadi kita sudah melakukan 3 kali tes Man-Whitney-U, maka p-value-nya untuk menentukan apakah itu signifikan atau tidak, kita harus melakukan Bonferroni correction or Bonferroni adjustment, yaitu membagi alpha value-nya kita. Alpha value-nya tadi kan disepakati 0.05 untuk menentukan apakah ada perbedaan signifikan atau tidak. 0.05. Rule of thumb kita akan pakai ini. P-value-nya. Ini harus dibuat menjadi lebih stringent. Dengan cara dividing the alpha value 0.05 by the number of the test. Ada berapa kali tes tadi? 3 kali tes, yaitu membandingkan kelompok 1 dengan kelompok 2, kelompok 2 dengan 3, 1 dan 3. Maka 0.05 dibagi dengan 3 kali jenis tes. 3 kali tes itu menjadi 0.015. Jadi ada hubungan atau tidak antara kelompok 1 dan 2 itu tidak lagi 0.05, tetapi less than 0.015. Jadi menjadi lebih stringent lagi, lebih ketat lagi. 0.015. Jadi 0.05 dibagi 3. Jadi kalau masih di atasnya ini seumpama 0.04, kalau menurut alpha value yang awal itu masih disebut there is significant difference. Tapi setelah dilakukan correction, Bonferroni correction, tidak lagi karena alpha value-nya harusnya less than 0.01 or equals or less than 0.04. And then you also need to calculate effect size like the way you calculate effect size using Man-Whitney-U test. Memang tidak sepraktis menggunakan ANOVA. And then this is the way you report the result. This is the example from my own project. Tadi sudah saya tunjukkan artikelnya. Kruskal-Wallis H-test were run to examine whether there is significant difference in the use of the 3 strategy categories between students with different English self-efficacy level, low, moderate, and high. Students who had different English self-efficacy level showed significant difference in their cognitive chi-square. Tadi saya ingatkan informasi apa yang perlu dicatat, yaitu chi-square ini. And then degree of freedom, this is the result of chi-square, and then p-value. Socio-affective chi-square, degree of freedom, and then p-value, metacognitive. Jadi ini 3 kali Kruskal-Wallis test. Kruskal-Wallis pertama, Kruskal-Wallis kedua itu, pertama itu yang kognitif, Kruskal-Wallis kedua socio-affective, Kruskal-Wallis test ketiga adalah tentang metakognitif. Jadi 1. Cukup butuh 1 kalimat untuk mereport hasil. 2 kalimat. Having determined that the difference existed, pairwise comparison using adjusted p-value were conducted to locate where the differences lay. Nah, karena ada perbedaan signifikan, maka pairwise comparison atau post hoc test dilakukan dengan melakukan adjustment pada p-value. Tadi apa? Bound for any correction. Ini saya menggunakan istilah adjusted p-value. Untuk mengetahui perbedaannya di mana, ya ada perbedaan dalam di sini strategi use. Tapi kan kita tidak tahu perbedaannya antara kelompok tinggi, rendah, atau moderat. Maka perlu dilakukan post hoc test-nya. Nah, post hoc test hasilnya bisa kita lihat di tabel. Di variabel kognitif. Jadi di variabel kognitif post hoc test-nya perbedaan antara kelompok L, mediannya kelompok L, kelompok moderate, and then kelompok high. 3, 3, 4. Kemudian perbedaan antara L dan M, signifikan atau tidak? Perbedaan antara L dan M signifikan. Antara low dan moderate group in terms of their strategy use, yes 0.000. Kan ini masih di bawah 0.015. Di bawah itu maka signifikan. Kita lihat di effect size-nya, R-nya, skornya R, 0.20. Ini effect size-nya. Kemudian antara low dengan high, signifikan. Look at the effect size, 0.49, moderate. And then between moderate and high, this is also significant, less than 0.015. Point di sini, effect size-nya 0.27. Di Kroskal-Wallis yang lain tentang socio-affective strategy, the median score for the low group is 4, moderate is 4, and then high group is 4.5. Look at the p-value less than 0.000, less than 0.001, less than 0.015 semuanya. Nah, kecuali ini, between moderate and high, 0.08. And then in metacognitive strategies, the median is 344, and then the p-value significant in all pairwise comparison between L and M, L and H, and also M and H. So this is the way you report the result. Look at the result of the way I report the result of the pairwise comparison. I no longer mention the p-value, the median score, or the p-value in the text. Semuanya sudah ada di sini sehingga mengurangi pengulangan. I simply show that table 4 show that the use of cognitive, socio-affective, and metacognitive strategies was significantly different in all pairwise comparison, except in the comparison of socio-affective strategy used between moderate and high. This one. The significant difference reflected a linear trend. That is, the students who perceive themselves as more capable of performing English tasks were likely to use cognitive strategy, blah, 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 more than those who didn't. As the R value suggested, the English self-efficacy had a stronger link with cognitive strategy than the two other categories. Jadi interpretasinya ditambahkan di belakang. Okay, now we will practice running Kroskal-Wallis test in SPSS. Okay, using the same data, I want to examine whether there is significant difference in the designing test assessment instrument in administering scoring and scoring assessment result, alternative assessment, validity and reliability. Jadi in all aspect of the assessment literacy, is there any significant in the 5 dimension or 5 aspect of assessment literacy between 3 different groups, between novice teachers, teachers with moderate experience, and also senior teachers based on teaching experience. Now, click Analyze, non-parametric test, legacy dialogue, K independent sample test, and I move all the dependent variables of dependent variables of interest. Okay, and then the grouping, service teachers. Oh, hang on. In service teachers, it should be nominal. Okay, done. Analyze, non-parametric, legacy dialogue, key independence capacities. Okay, and then teaching experience, grouping variable, and then define group 1 until 3. Tadi ada 3 kelompok, guru dengan pengalaman baru, guru yang cukup senior, dan guru senior. Nah, di sini maksimal and minimum. Jadi tidak ada kata 1, 2, 3, tapi 1 and up to 3. Karena ada 3 kelompok. Kalau semua ada 5 kelompok, ya 1 to 5. And then, by default, cross-call wall is already checked off. And then, option, descriptive statistic. And then, okay. Okay, we already got the SPSS output, non-parametric test, look at the mean score for the 5 dependent variables. But we don't need this item. Look at the number of participants, 34, 33, the mean rank. Looking at the mean rank, it seems that there isn't any significant difference in between group 1 and group 2, group 2 and group 3, group 1 and group 3 in designing tests. This is also the case in the second variable, administering and scoring assessment result. But it seems that there will be a significant difference between 1 and 3, group 1 and group 3, in terms of validity and reliability. Look at the mean rank 47 and 40. Oh, sorry. 47, 1 and 2, and also 2 and 3. Maybe, but we need to check this whether statistically they're also different. Look at the chi-square. Okay, significant value, whether there is a significant difference or not between the 3 groups. Look, the significant value greater than 0.05, greater than 0.05, all. Tidak ada yang sama, tidak ada yang perbedaan signifikan, all the same. Jadi tidak ada yang perbedaan signifikan semuanya. Ketika tidak ada perbedaan signifikan seperti ini, there is no need to have follow-up pairwise comparison or post-hoc test. Jadi tidak perlu dilakukan post-hoc test. In case ada perbedaan signifikan di sini, semua significant value-nya itu 0.05, less than 0.05, then you need to run man with NIU. Jadi harus melakukan tes man with NIU. Berapa kali? 3. Sesuai dengan kebutuhan tadi 3 kali. membandingkan antara kelompok 1 dengan kelompok 2, 2 dengan 3, 1 dengan 3 di setiap tes Kruskal-Wallis yang signifikan. Tapi kebetulan di sini tidak signifikan sehingga tidak perlu dilakukan a series of man-Whitney test untuk melihat perbedaan antar dua kelompok sebagai follow up atau post hoc comparison. Okay, any question? Okay, if there isn't any question, this is good. It means that it's already crystal clear, and what you need to do is you have to practice. Of course, okay, Riza. Yeah, Riza.
So, I want to ask related to ANOVA, but so it's out of the topic today.
Yeah.
Yeah, I'm sorry that I couldn't present because I joined late. But what I want to ask is, you said that the effect size must be calculated each each variable. For example, introvert and extrovert and ambivert and introvert, like that answer. But according to our practice, that the effect size is using only one column, which includes total and I forget. So how to calculate each aspect like that, sir?
Oh yeah. Yeah, okay. You need to run a kind of like a t-test, Mbak. Jadi semacam t-test itu beberapa kali sehingga bisa mengetahui effect size-nya. Memang kalau yang di ANOVA-nya sendiri, you only get the overall effect size. Jadi from the SPSS output, itu from ANOVA, you only have the data about the effect size of the significant difference of the all groups. Jadi perbedaannya untuk semua kelompok di ANOVA yang dianalisis dengan ANOVA, sehingga sifatnya umum. Tapi jika kemudian ingin menyajikan di perbedaannya di setiap kelompok, setiap tes antara kelompok 1 dengan 2, 2 dengan 3, 1 dengan 3, maka analisisnya seperti menghitung ala t-test. Pakai alat t-test, betul. Apakah ini wajib? Tidak wajib. Makanya contoh dari saya kan tidak model seperti itu kan, only one. Yeah. Ya. Kenapa? Karena di SPSS output-nya hanya menunjukkan overall, sifatnya overall. Sedangkan kalau mau lebih detail lagi, ya itu tadi analisis sendiri. Tapi sebenarnya satu cukup, nggak apa-apa. Yang penting ada effect size. Karena itu sekarang menjadi compulsory itu. Kalau menurut APA compulsory.
Okay, so if we want to calculate all, we only need to calculate by ourselves.
Iya.
I mean,
hitung sendiri.
Without any feature in SPSS like that, sir.
Iya, not based on the SPSS output of ANOVA. Nggak muncul kan SPSS ANOVA-nya? Iya, nggak ada. Nggak muncul.
Okay, sir.
Iya.
Okay, sir. Thank you, sir.
Oke. Nanti ketika yang lain, tes-tes yang lain seperti MANOVA atau yang lain itu nanti akan muncul sendiri. Eta square-nya, partial eta square. Tidak perlu hitung manual. Memang kalau yang analisis yang basic seperti t-test itu terus Kruskal-Wallis seperti ini, Anda you have to calculate manually. Tapi kalau sudah nanti MANOVA atau yang advance, ya seperti MANOVA, itu sudah part of the result, part of the SPSS output. You don't need to calculate manually.
Okay,
Yeah.
sir.
Okay.
Okay, we'll practice. Thank you.
Okay. Any other question? Oh yeah. Please collect the result of your ANOVA null. The assignment for ANOVA collectively. Jadi ANOVA-nya yang sudah dikerjakan silakan nanti dikumpulkan secara kolektif to me. For Kruskal-Wallis and Man-Whitney test, you can practice using the same data, tapi kalau menurut saya nanti datanya di make up lagi. Datanya di make up, karena tadi ketika saya run pakai Kruskal-Wallis, data yang ada itu tidak ada perbedaan signifikan. Coba nanti di make up datanya, jadi hasilnya bisa tampil signifikan, ada perbedaan signifikan. Research question nanti Anda menyesuaikan sendiri. Make a research question which should be addressed using Kruskal-Wallis and also Man-Whitney test. Okay, then, if there is no questions, then we will end the class. And remember, you need to practice analyzing using the two non-parametric tests we learned this morning. And then next week, I will ask some of you, like usual, to practice it and then to show the result of your analysis. Remember, make up the data so that the result will be significant. So that you can have a kind of follow-up post hoc test. Okay, thank you. See you next week, inshallah. The last meeting next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh.
Thank you, sir.
Salam, thank